These days, I need that bioreactor to churn out product all day and all night. Bioreactor. B-I-O-R-E-A-C-T-O-R. Bioreactor. If you look on Google book search for the word bioreactor, the word doesn't really start appearing in books until past 1940, 1945, something like that. And then it really starts to take off around 1970 because we started to make much more vaccines, antibiotics, biological materials. All these things were created by engineers with the use of bioreactors. A bioreactor is just a system used to help cultivate a bunch of organisms to make them do what you want to do. And if you look at it, you might typically think of a vat or a giant barrel, a fancy metal barrel, something like that, where you can grow things inside. Maybe it's bacteria that you've engineered to produce some particular antibiotic. These days, you might engineer organisms or microorganisms to produce vaccines, maybe against COVID, maybe against the flu. Nowadays, you might even think about producing artificial meat or lab-grown meat to get that strange image in your head, but that's produced by organisms that might produce proteins at that microbiological level. So very often we talk about bioreactors as systems where you control the temperature, you control the ions and nutrients in a broth, where you can really cultivate and nurture the specific organisms that you want to grow. And if you do it just right, they undergo their own biological processes to produce a product. Also these days, a bioreactor might be used to break down a product in a very specific way. Maybe you want to break down organic materials. Maybe break down those materials in a way that helps the environment, And really, the limit is your imagination, or the imagination of engineers and scientists. What can you do with millions and millions of microbes growing and working together exactly how you want them to? Not only are there pharmaceutical or medical applications, but there could be those environmental applications. There could be those nutritional or ethical ramifications when you start creating your own foods or meat replacements or meat substitutes. And then you have these connections to joy and fun. It's not all creepiness. I mean, making beer or making wine in a way that's a kind of bioreactor, you're controlling the yeasts that ferment at a very particular and controlled rate. And bioreactors have different senses of scale. They could be big or small. Small in that batch process level. Maybe you're making antibiotics in small little amounts every day, kind of like making ice cream at home. Or you have industrial ice cream factories, right, that are just continuously churning out ice cream. Well, you could have continuously functioning bioreactors as well. And that's where pharmaceutical companies come into play, where you have chemical engineers and biomedical engineers and mechanical engineers designing these systems to make these microbes happy. Let them grow, let them produce that medical product that you want, and then collect them. Clearly, bioreactors are going to remain in the engineering lexicon, given how important they are to our survival. And that is why bioreactor is my engineering word of the day. This is Pius, your host of Engineering Word of the Day. I do all sorts of stuff related to engineering education, including this podcast. And if you want to support me, you can go on Patreon to show that support. Go to patreon.com/PiosLabs. That's PIOSLABS. Thanks for listening.